So this is the first lesson from chapter 3, which we're going to look at exponential and logarithmic functions. On the board here you can see the objectives for that chapter, and we're going to specifically focus on the two ones in a different colour there for this first lesson. Now some of this should have been covered in Algebra 2, but often this is towards the end of the course. It's only a very small section of Algebra 2, so it's often gone over very quickly. Now, I must admit this is one topic that I often have a little bit of confusion on. Sometimes I mix things up before, so I came up with this little mantra to try and get me to remember the correct way of actually doing this thing. So in my head I tell myself left, right, middle, and what that means is when I've got an expression like this, log to the base a of a number equals something, then what I do is I start on those three letters here, a, y and x. I go with the left one to the power of the right one equals the middle one. So in other words, a to the power of x equals y, and then using my symmetric property I can just flip those over and say y equals a to the power of x. Now if you see this with numbers, often you'd be given just what is log to the 2 of 16, and you'd have to know it's 4, but the reason is 2 to the power of 4 is 16. So it's the same, left to the power of the right one equals the middle one. So I use that little tool just to try and help me to make sure I have actually worked these out correctly. Now you could be asked to convert this into this, or you could be asked to convert this into this. So it's the same idea. If I am given this one, then I look at the one with the power first, and I'd say, okay, this is the one that's going to go on the left, this is the one that's going to go on the right, and then this number is the one that's going to go in the middle. So I know these two parts are going to be on the left and the right hand side. So let's look at a few examples to see what this actually would look like then. So we might be asked to find a value of x. So if I was working this out using the left, right, middle, I would say 5 cubed equals x. And then I can just work out what is 5 cubed. Well, it's 125, and then I've figured out what the answer is. Move the place of the x this time, same idea. This to the power of this equals this, left, right, middle. And then I can go ahead and solve that equation. So to find what x is, if I do the fourth root of 2,401, then I can find out that it's 7. If you don't have a fourth root button on your calculator, you can also do to the power of 1/4 as well, and that would also give you the answer. Last one where I've changed the value of the x here, put the x on the right hand side this time, so 16 to the power of x equals 4, or 4 equals 16 to the power of x. And from this I should be able to figure out this is actually a square root question. The square root of 16 is 4, and the square root is the power of 1/2. So the answer is just 1/2. Oops. And our last one looks a little bit more confusing because actually I haven't given a base for this question. And one of the assumptions for this topic is if we're not given the base, then that means that the base is 10. So what we can say here is 10 to the power of x equals 1,000. Oops. Like so. And therefore x is 3 because 10 cubed is 1,000. So if the base is not given to you, you might just want to make it base 10 anyway. Now the other thing you have to be able to do is do the rules of logs. And the main rules of logs I put up on the board here. So if you've got the log of something plus the log of something, then you can actually multiply the two things together and combine it into a single log. So for example, the log of 4 plus the log of 3, 4 times 3 is 12, so I can just say it's log 12. Now that is provided that the bases are the same here. Now I haven't just put base 10 here because it works for any base, but the bases must be identical for both if you're going to combine them like that. Now similarly, if you're subtracting, then the rule is you're going to divide here. So log of a minus log b, you do the a divided by b. So if I did log 24 minus log 8, 24 divided by 8 is 3, so I can combine them. This is very similar to what you did with exponents. When you multiply, so for example x squared times x to the 5 is x to the 7 because you add the exponents. So when you were multiplying, you added the exponents. So it's a similar thing but in reverse. So with logs, when you add, you multiply the letters together. When you subtract, you're going to divide them. Third rule of logs, if you've got the log of something raised to a power, you can bring the power to the front of the question. So this is one where you look at log 8 and you think that's a perfectly good answer. When you look in the back of the book, you're going to see 3 log 2, and you're going to say, well, how come I got a different answer? Well, the reason is 8 you can write as 2 cubed. So the log of 2 cubed, bring the 3 to the front, and you get 3 log 2. That's a rule that a lot of people miss when they come in to simplify their answers. So with logs, make sure you can't write the number as something to a power of something, because if you can, then you can simplify. And very simple rule of logs. Log of 1 is 0. If you forget that one, you can always type it in your calculator anyway, and it will tell you that it is 0. So a few examples using that idea. So this is the first rule of logs, because I'm adding here, which means I'm going to multiply the two things together. So 4 times 7 is 28, and I wouldn't expect you to show that step of working. You can just go ahead and write down that answer. Second one. This time it's the second rule of logs, because we're subtracting, which means we're going to divide the exponent. So 20 divided by 5 is 4. And actually for this one we could write 4 as 2 squared as well. So we could also put 2 log 2 for that answer, which would be even better. Now this time, just like your rules for radicals and general collecting terms, as long as they're alike terms, I can add these together. So 3 log 2 plus 1 log 2 would give me 4 log 2. You could possibly bring this exponent up using the reverse rule here and say it's log of 2 to the power of 4, which is log 16. But that's the most simplified answer we can have. Let me scroll up so we can look at our last few. Now this time I can't add these together because these aren't like terms. I've got log 2 and I've got log 3. So I have to use that third rule of logs in reverse here. So if I have this, then I know I can bring this up as an exponent so it looks like this. So 3 log 2 I can write as log of 2 to the power of 3. And I can write this one as log of 3 squared. Then I can work out each one independently. So 2 cubed is 8, 3 squared is 9. And now I can go back and I can use the first rule of logs because I'm adding two things with the same base. So 8 times 9 is 72. So a very important one to keep an eye out for when you're collecting terms. This suddenly looks a lot more complicated. Expand means we're going to write it as several different logs, so we just got to think what we're actually doing here. So the ones on top are all multiplied together and the one on the bottom is divided. So when we're multiplying, we know that's the logs added together, and when it's divided, we know that that's subtracted. So I can split it up like this. Now I can also use that third rule of logs as well. Any exponents I can bring to the front. So not quite as complicated as it might first appear. Now this one looks a lot more complicated. We've got a square root in here. We've also got several things on the bottom of the fraction here. So the ones on the bottom we know are divided, so that means we're going to do subtractions. Also this square root we know it means to the power of a half. So we can say it's all of this to the power of a half, and using that third rule of logs, any exponents we can bring to the front. So we could say it's a half times by, and then we can start splitting this up. So the half once again comes from the radical, and then anything that's on the bottom means I'm dividing. So I'm going to do a subtract for each of those questions. Any exponents I could also bring to the front. I chose to distribute at this point, but I could also do them in a different order. And on the last step here, the 2 came to the front, and a half times 2 is just 1. We don't write 1 log z, just like we don't write 1x, we're just going to put x. And that should be enough information for you to try the two exercises that you can see in School Fusion.